Behind me is a very interesting number theory equation. We have a and b not exceeding 1000 to be positive integers such that this equation holds. Now, note that GCD denotes greatest common divisor or greatest common factor. So, you want to find the largest possible value of a plus b. Go ahead and pause the video and try to figure out a solution on your own. Done? Alright, let's get started. Firstly, it's not really easy to analyze a and b on their own, right? I mean, it's not really immediately obvious what a and b themselves should be. However, maybe we can try analyzing the GCD of a and b as a whole, right? And can we somehow connect these two terms to this? Well, if we don't know what the greatest common divisor of a and b should be, then we'll just call it n, okay? Now, if this is so, then how can we write a and b? What do you guys think? Well, if the greatest common divisor is n, then a should be equal to n times p, where p is a positive integer, and b should also equal to n times something, so just call it q, where q is also a positive integer. But here's the thing. In order for n to be the greatest common divisor or greatest common factor, we need to have GCD of p and q to be 1. Because otherwise, n itself would not be the greatest common factor. So we need to have p and q to be relatively prime, or, for the greatest common factor to be 1. Okay, so given this is true, what can we say about a squared and b squared? Well, squaring the equations, we have a squared is equal to n squared times p squared, and b squared is equal to n squared times q squared. Okay, so what is the greatest common divisor of a squared and b squared? Well, you can see that n squared is a common factor. Now, do p squared and q squared have any common factors other than 1? No, because they were relatively prime, so their squares should also be relatively prime. Therefore, the greatest common divisor over here is just n squared. Now, note that if we were to cube the equations now, so we get a cubed equals to n cubed times p cubed, and I think you're understanding where we're going at this point. But if you were to cube the equations, then note that again, p cubed and q cubed obviously should be relatively prime, so therefore, the greatest common divisor of a cubed, b cubed is equal to n cubed, right? So as you can see, I'm going to draw a line over here so it doesn't get mixed together. So as you can see, we've deduced the values of GCD of a squared and b squared, and for a cubed and b cubed in terms of n. Okay, so I've written what we've deduced over here. In particular, if GCD of a and b is equal to n, then these two following equations must also hold. Therefore, this equation over here is transformed to n plus n squared plus n cubed is equal to 258. Much better. Now, I know it looks like an annoying cubic, but it's not annoying because n needs to be a positive integer. And this side grows pretty quickly. I mean, if you were to plug in n is equal to 7, then 7 cubed is already bigger than 258. So just test all integers from 1 to 6. Surely that's not a problem. Now, you'll actually find that n is equal to 6 is the solution. And therefore, we can deduce that the greatest common factor of a and b is equal to 6. Now, if we know this, then it should be no problem to find the largest possible value of a plus b. Now, remember, they cannot exceed 1000, right? Now, firstly, because the GCD of a and b is 6, then this would mean that a is equal to 6 times p, where p is a positive integer, and b is equal to 6 times q, where q is also a positive integer. But because 6 is the greatest common divisor, then this would mean that GCD of p and q must be equal to 1. Now, remember, they cannot exceed 1000. So therefore, for p, in order to maximize a, then we can take p to be 166. Anything larger than 166 would exceed 1000. Now, for Q, we also want to make it as large as possible. However, it has to be relatively prime to P. Well, you'll actually find that Q is equal to 165 does the trick. In fact, any two consecutive positive integers must be relatively prime to each other. Okay, so now that we've got our values for P and Q, it should be no problem to just sum what a plus b is in this case, right? So therefore, our answer, the largest possible value of a plus b, is 6 times 166, and then plus 6 times 165. Now, if you were to actually evaluate this sum, this would be 1986. And this would be our final answer. Now, note that the strategy for this problem was not to analyze the variables independently, but to analyze something that grouped the variables together. In this case, we analyzed the greatest common factor of a and b together, and this allowed us to deduce the values for this and make some relations and get our answer. So yeah, when you are faced with a tough problem involving a lot of variables or somewhat of a complicated equation, then try to analyze a group of variables, not just that variable independently. Anyways, thank you very much for watching this video. If you found it useful, if you found it interesting, then please consider dropping a like and subscribing. Thank you very much. Bye.